welcome to our session. My name is Haitao, and this is Xiaobing. We are software engineers from StarTree. Today, our topic is Minions to the rescue, tackling complex operations in Apache Pinot. Our presentation will flow as follows. In the first half, I will first introduce the complex, tedious ways to operate Pinot without using Minion. Then I will introduce how we make use of Minion to make the Pinot operation to be automatic, hand-free, and code-free. In the second half, Xiaobing will do a deep dive into the Pinot native Minion task framework and why the framework is easy to operate and easy to extend. At the very end, Xiaobing will also introduce our future work, including extending the framework itself and building more functions on top of the framework. So let's first take a look at Pinot. So as an OLAP database, the major function of Pinot is to run SQL queries to analyze a large amount of data in real time. To optimize the query paths, the Pinot team follows a list of guiding design principles. First, the system should achieve low query latency even at a very high QPS. Secondly, the system should be highly available, which means that even a single instance or some components in the system fails, the whole system should continue to serve query and perform correctly. Third, the system should be horizontally scalable, which means we should be able to scale the system by simply adding new nodes to support increasing workloads. Last but not least, the system should be easily extendable while plugins, which means that users are not limited to the functions provided natively by Pinot itself. It's easy to extend. To support performance queries, similar to all the other OLAP databases, there are several major types of operations running behind the scene. Let's take a look at them one by one. The first type of operation is data ingestion. So data ingestion is essential to get data in the system from various data sources. For example, the data source can be streaming system, can be data lake, can be blob store. The data can also be of very different format, including, for example, Arrow, CSV, JSON, Parquet, a list of them. So we use the data ingestion to make the data to be queryable in Pinot, and also we guarantee data completeness. The second type of operation is data update. The data update means once the data is in the Pinot system, we may need to modify them. So typical examples including GDPR data pruning. So that means users, for some reason, they want us to delete the data. And the other example is record update. So we want to keep the data consistent with the data source when some of the data has been updated. The goal of the data update is to keep the data in the system is always correct, and also we want to protect the user's privacy. The third type of operation is data reformat, which again means that we want to reformat the data in the system. For example, we want to compact data. We may want to resize the Pinot table. We want to resize the segments. We want to repartition the data. The reason why we want to do data reformat is because as your traffic grows, as your data volume changes, or maybe you want to scale your Pinot system, right? But if we keep the table static, then that cannot achieve the best performance of Pinot. So we should always try to tune the segment size, the table size, to make the best of Pinot. So let's jump out from Pinot for a second. So how to perform those operations in general? So let's take a look. For each type of operation, typically there will be two types of way to achieve the goal. In place data operation by existing components, or the users, they build their own pipeline using third-party tools like Spark or Flink or any other tools. So for users, usually they prefer, so in general, users prefer inbuilt solution because that means they don't need to spend time to try to learn yet another system, and they don't need to spend time and spend resource to build other system to perform the operations. So what they do simply is just, okay, configure the system. Here, in our case, is configure Pinot to do the work for them. So let's jump back to Pinot again and see how those operations are supported when Minion is not used. So as we know that in Pinot, there are two typical type of tables. Of course, there's a third type is hybrid table, so we can ignore it for now. So two type of tables, real-time table and offline table. So we will separate them and introduce the operation for each. To perform the data ingestion for real-time table, if we are not using Minion, then Pinot servers natively support pool data from a list of data sources like Kafka, Kinesis, and others. For offline table, users, they need to build dedicated pipeline using like Spark, Hadoop, or Pinot itself, we provide a standalone ingestion framework. So users can also make use of that to build data ingestion pipeline. For data update, again, for real-time table, Pinot servers can perform two type of updates natively. So that's data update and dedupe. For other types of update, users, again, they need to build dedicated data re-ingestion pipeline, and then they need to find a way to replace the data in Pinot automatically. For offline table, users always need to build a data re-ingestion pipeline and try to replace the data in a proper way. Talking about data reformat, for both real-time table and offline table, there's the only solution, if there's no Minion, is users, they need to build their own pipeline. So we see that the operation matrix is pretty complex. Indeed, we see several operation challenges when we were not using Minion. So here we list several of them. First, the operations, they are fragmented and complex. So users, they need to, in addition to Pinot, users, they need to set up and maintain some other systems. So if the other system, they have problem, so users, they also need to spend time to debug them, to fix them. The second challenge is some operations, they are manual, tedious, time-consuming, and error-prone. For example, if users, they just want to ingest data, or they want to do one-time data update or reformat. So what they do is they spend time to learn their need and then do a design and then set up the pipeline and do the work and then just throw the pipeline away, right? So this is a pretty manual and then time-consuming. The third challenge is some operations are hard to achieve. So think about the case we want to do the previous mentioned data repartitioning and resizing. Is there a good way? That's a question mark. So seeing those challenges, we want to build a better solution. So that's when and how the Minions come to the rescue. There are several considerations when we build this ideal solution. The first consideration we have in mind is we want to make the operation to be much easier. So we want to minimize the dependency on third-party systems and pipelines. Ideally, there should be no other pipelines or system needed. The second consideration is we want to unify the Pinot control. So that means, so with this, so it will be easier for us to guarantee the operation is atomic, and also there's no downtime for the Pinot system itself. The third consideration here is we want to separate the concerns. So that means if we want to make use of the Pinot itself, Pinot component itself, to perform those operations, because those operations, as you see, it may be very heavy, right? So we don't want to affect the performance of other logic, especially the query paths. So we don't want to affect the performance. We don't want them to slow down. So that's all the three key considerations we have. So the next question is, what is Minion? So Minion, as shown in this figure, Minion is a Pinot native component. So it is designed for complex and generic operations. It is a standalone component that can offload the very heavy operations from other Pinot components. For example, offload the load from Pinot controller, broker, server, any other components. And it is easily attachable to any existing running Pinot system and take tasks from the Pinot controller and do them, and then just try to modify the table or anything in the Pinot system without affecting the performance of other components. So next, I will just, so Xiaobing will talk about the details in the second half. So now I will use two Minion tasks as examples to show how we tackle very complex operations in Pinot. The first example is file ingestion task. So the file ingestion task at a very high level is an extension to ingest files from file systems, any type of file system. For example, blob store like S3, GCS, ADLS, or even like local FS. So it can ingest file from all those kind of file system to Pinot. So this file ingestion task has two key features. The first feature is it can do data ingestion exactly once. So that means there's no data missing, there's no data duplication. And also we can do some pre-processing with the file ingestion task. For example, the data transformation, we can derive new columns, we can omit some of the columns, we can merge some of the rows. We can also do data partitioning, do sorting based on some of the columns. So that's the two key features. And we use this task to replace our earlier solutions that build on top of third-party solutions like Spark. So this greatly simplifies our work to ingest data. So actually, this file ingestion task can run in different modes. Here I list the three modes we support. The first mode is bootstrap, which means that we can ingest data that will not change. So this is usually for one-time data ingestion. And we can also support sync mode. Sync mode means that the data source may have some changes over time. For example, some of the line change, you completely replace one of the file. And this file ingestion task, it can monitor the source data change and automatically re-ingest the data and keep the data stored in Pinot to be in sync with the data source. And the third mode is incremental ingestion. Over the time, for some use cases, they may add more and more files into the data source. And users, they don't want to yet create another pipeline, or they don't want to set up new logic to ingest those files. So this file ingestion task can also detect those new files and then automatically ingest them into existing Pinot data tables. The second use case is called segment refresh task. This is yet another extension that supports refreshing table segments. The key features is it can automatically detect table config change, and it will refresh the existing segments of the table to make them to comply with the latest table config without any human intervention. And the key of this task is that it makes impossible possible now. For example, previously, how do you do data repartition? How do you try to change the sorting column, right? So with this segment refresh task, we can do them easily now, just by setting it up. And then you just go directly to change your table config. Everything will just happen magically. And here is a list of operations that can be done by the segment refresh task. So it can do time partitioning. It can do value partitioning. It can also do some merge and split work, even after the data has already been ingested into Pinot table. So for example, now I think the segment is too large, and I don't need such great granularity of the data. So I can just change the table config, and then this task will automatically try to merge some of the value and to reduce the segment size. And it can do many more. For example, change the time column, change sorted column, even change data type and the underlying encoding. So now I will hand it over to Xiaobing to talk about some of the details.
Cool. Thank you, Haitao. So in following sections, I'm going to walk you folks through how things works under the hood. So Mini task framework is actually built on top of this Helix task framework. Helix task framework is part of the Apache Helix project, which has been used by Pinot for cluster management, which proved to be super resilient at very large scale. And as you can see in this figure, this Helix task framework actually provides a very flexible way for you to define tasks, and the framework will just handle all the task scheduling very flexibly as well. And the top level of the abstraction is called workflow, and a specific workflow is basically a job queue, which is a first in, first out queue. And the workflow is composed of many jobs, and jobs can depend on each other in some graph-based dependencies. And the job is still a logical concept here, and it can be broken down into many tasks, which will be running on like many physical machines in parallel. And the task here is the most basic execution unit. So this is the Helix task framework. If you look into it, it's actually very flexible. And, but sometimes this flexibility is kind of like not super required by the Pinot specific use cases. So on top of this, we actually built this Minion task framework. And this is also the task Haitao just showed, which kind of like used. So this framework actually is kind of like a simplified abstraction on top of this Helix task framework. And there are two major interfaces. One is called Pinot task generator, which is something running inside the Pinot controller. And this is a part to decide how to break down the work into smaller pieces. And the second interface is called the Pinot task executor, which is running on mini workers, which is basically just a set of servers which are independent from the other Pinot components, like a Pinot server, Pinot controller, and Pinot brokers. So those mini workers just a separate pool of servers to do those like heavy data processings. And also the second thing is we don't really need those flexible and complex graph-based job dependency support. So we basically just model it as a batch of tasks which can run on those workers in parallel. And we just let Helix to schedule those tasks and monitor those runtime stats. And regarding another critical part is failure handling. So the Helix framework provides some like inbuilt task retry mechanism, but considering failure handling is actually very specific to some like the work you are trying to do. So we try to we basically disable the inbuilt retry mechanism by default, and we make it explicit that the task generator or executor need to handle the failure based on their specific need for the job to be correct. So I will have a few examples to show more details about the failure handling because it's just very critical part of the task. So if you want to add a new task type for your own use cases, essentially you just need to implement these two major interfaces. The task generator is where you want to put your logic about how to break down a big work into multiple smaller pieces which can run in parallel. So the output of this task generator is just a list of Pinot task config. So this list is just basically submitted to Helix, and Helix will keep them inside a queue and dispatch those to the Minion workers to run in parallel. And so one Pinot task config essentially will be used to initialize one task executor I'm to show in the next slide. But here, basically, in the generator, you think about how to break down the major task to smaller pieces. So, for example, in the file ingestion task, in the generator, we basically try to list the files in the input folder, and also ask Helix to tell the generator any task failed in the previous batch, and also check some checkpoints to say any files is already ingested. So we just skip it so that we don't like ingest files multiple times for data, which may cause data duplicate. So with those information together, the generator can decide how to schedule the next list of Pinot task configs to ingest maybe a few more files into the Pinot table incrementally. And yeah, so this is a task generator. This is where you decide how to create this list of Pinot task config for the next batch of data processing. The second interface is this Pinot task executor, and essentially just taking, so each executor takes in one Pinot task config to like figure out which piece of the work it need to do, and every single Pinot task executor run inside a single thread. So you may have multiple Minion workers, and on each single worker, you may have multiple threads, and all those executors just run on those kind of like a big group of threads in parallel. And as an example here, so in file ingestion task, the task executor is basically where it download the input files and process it. It can do like a transformation, like a merge rollup, and some generating the segments based on the provided size requirement, and then upload those segments to the Pinot tables. And at the end of the execution, it will also report the task states back to Helix. And Helix will just track those task states, and later on the generator can just look into those task states to decide if any task actually run into failure and try to do some failure handlings. So those two major interfaces is basically where you decide how to break down the task, or how to break down the work, and how to run those individual pieces in parallel. But you will get some failures sometimes in the task executor. And this is where you need to think about how to do failure handling. So even though Helix provided this inbuilt retry mechanism, but sometimes for a proper failure handling, you need to access some like extra context which are not available to Helix framework itself. So example here is like in the file ingestion task, we actually keep some checkpoints information inside the Zookeeper. So this checkpoint information basically is a mapping between the input files and also the generated segments already inside the Pinot table. So when the generator kicks in again, try to figure out what's the next batch of task, it needs to check these checkpoints and also ask Helix about the task status to identify some like task failures. and then try to, and also identify is there any file that's not able to be processed and it need to skip it. And also, a third thing is it need to figure out if there are any segments need to be removed before you try to redo those input files. So all those information, context is actually available only to the generator. And so that's where we actually have the generator to handle the failures. If we just rely on the retry mechanism provided by the Helix task framework, so there are some corner cases not able to be handled very well. So another example is in this segment refresh task. A key requirement here is you need to replace the segments atomically. For example, you want to combine 3 segments into a larger one, and you upload these larger segments into the Pinot table. If without any other mechanism, the query will see like the data duplicated between those 3 old segments and the new larger segments. So for the replacement to be atomic, we actually utilize a feature which is called segment lineage, which is available in the open source Pinot repo today. And this segment lineage feature is basically a data structure inside Zookeeper so that we can do this replacement atomically. Essentially, it's basically you upload the new segments, but you switch some flag inside of this segment lineage Z node so that the new segments will become visible to the query, and the old segments will become invisible to the query, kind of like in this single atomic switch. So that's a key requirement for this segment refresh task, and this is also where we handle the task failure. And as you can see, segment lineage is not something within the Helix task framework, so we have to do this failure handling outside of it. And the high-level takeaway here is when you think about the failure handling, likely you need to think about it as part of your task generator logic, or maybe some part of your task executor also need to be provide some information for failure handling to work properly. So that's how you can extend the Minion framework for your own use cases, basically the 2 major interfaces, and also how to handle the failure properly with the logic inside of those 2 interfaces. And assuming you are going to run this Minion task in a pretty large set of Minion workers, and you want to figure out how things works in the production, so you need some observability and management tool in hand. And for those, we provide following features. One is the Minion task management UI, which is part of the Pinot UI. So Pinot UI is basically where you can check all your tables and run some queries. And we also extended it to manage these Minion tasks. So from there, you can basically see all the different task types and all the individual tasks, the runtime stats, all the past results of those Minion tasks. And this management UI is actually use all those RESTful API on the right side. So if you have your own in-house operation infrastructure, you can also utilize those RESTful APIs to kind of integrate the automation task operation with your own in-house solution. Another thing is we report those metrics, so you can also collect those metrics to integrate with your monitoring and alerting system to operate Minion task framework easily. And another thing we actually have done inside the StarTree cloud is we added this auto scaling feature because we found the Minion task tend to run regularly, and it doesn't really sensitive to the latency to react on the request. So we just kind of added this auto scaling feature so that to let the StarTree cloud to decide when to add more workers and when to remove those workers so that we can reduce the operational cost. And the mechanism basically runs by relying on one kind of critical user input, which is the min and the max number of workers to provision. And then the cloud, the StarTree cloud infra will just monitoring all the metrics from the worker side and also the pending tasks to decide when to scale in and out the Minion workers. So that's about the Minion task framework as of today. And so we have those simplified abstraction on top of Helix task framework for you to extend it for like Pinot specific use cases. And also there are like management UI and all those kind of metrics to help you operate at a large scale easily. And looking into the future, we majorly think about to improve this Minion task framework from like two major perspectives. One is about the framework itself to make it more resilient and easy to operate. The second perspective is about using this framework to add more functionalities by adding new types of tasks. Regarding the framework itself, we think about to just make the auto-scaling a lot better. Like for today, so if a task just failed with some specific reason, we actually want to check what's the failure cause. If it's like out of memory or disk, we can think about to add like larger workers into the pool to retry the task. So it's basically try to scale up the instance or maybe scale down the instance based on some like fine-grained task runtime information. And another thing is like try to leverage those spot instances, which might provide more chance to reduce the cost of operations. Another area we see chance for improvement is the resource isolation. So today is pretty simple. So everything just kind of like sharing the resource on the Minion worker side. And also it share a single task queue inside the Helix task framework internally. So we want to add some isolation between tasks from different tables, which should happen on both task generation side and also execution side, as well as the task queue. If we can break down the single queue to multiple ones, we can also think about adding like priorities between those different queues to schedule the task among different tables more like properly based on the user need. And the third one is we start to see some use cases like we want to run multiple task types at the same time. For example, we use the data ingestion task to keep getting data into Pinot as segments. Meanwhile, we also want to run the segment optimization task to keep changing the format of those segments based on the changing query workload, which means the two tasks need to run with each other safely. And we are thinking about maybe it's time to reconsider those graph-based task scheduling and try to see if this can help make different tasks run with each other safely inside one Pinot cluster. That's a third thing. So regarding to extend, like adding more functionalities using this task framework, we are thinking about two ideas right now. So today we have task majorly for data ingestion and segment management, but we are also thinking about maybe we can use Minion task framework to support materialized view. Basically, you can create a new table, and the data inside this table is some pre-aggregated value based on some input tables. And we can have this Minion task to keep the data, keep the results in both in the aggregated table to be in sync with the data inside the base tables. And a second thing we can try is using the Minion task as some like integration point to put Pinot into a much wider data ecosystem. For example, we can schedule a Minion task to trigger some external service and just let the Minion task stay in there monitoring this external service and maybe in the end get the result spike and put into some Pinot table for the query to access those data in a kind of like a real-time manner. So essentially, we can think about using Minion to integrate Pinot into a much larger ecosystems. So that's the second. Yeah, that's about the future work, and that's actually all things we prepare for today's talk. So we have 10 minutes left. I think we can get some questions to answer.
So I had a question. Maybe I missed this, but the actual tasks get scheduled to run on which servers? Like how do I? Yeah.
So the Minion task is running on Minion workers. So which is a separate, you can think of it as a separate pool of machines, which is just kind of like running those tasks, doing those heavy lifting data processing, kind of like bring the load off the query path. Yeah.
Yeah, so my question was for the scheduling and orchestration of the tasks, it's done by the controller and Zookeeper under the Helix framework, right?
So I think that's like two parts. So the task generation, all those logic is inside the task generator. It's something like the developer need to implement. But the task scheduling, like you submit the list of task config to Helix, and Helix will in charge of how to dispatch the task to the workers and monitor the task runtime and report the task stats back. So it's kind of like a two-part. So the developer implement the generator, just think about how to break down the work into smaller pieces, and then just submit the smaller pieces to Helix task framework. And this framework will handle the dispatch, monitoring, keep track of the runtime stats.
Got you. I guess my question though is, I notice for the Pinot that we run, sometimes especially for very large real-time tables, there's a lot of pressure on the Helix framework. Typically it's managing the segment metadata and stuff in Zookeeper. And so I guess my question is if we had minions enabled and we were potentially ingesting tons of data each day, just daily increments, would that potentially also add more pressure to that whole system?
Got it. So the short answer is the Pinot generator run inside the Pinot controller, so which might need some extra resource to kind of do the task generation. And but it's supposed to be do things lightweight in this generator. You're supposed not do the heavy lifting data processing within the generator. That's supposed to be done in the executor side. But still, if you are kind of have so many tables and each table also have so many different task types to be scheduled, it might add some extra overhead in the Pinot controller, which might actually contain the resource which is supposed to be used for the real-time data ingestion, those kind of state transition management.
Got it. Yeah, that makes sense. Thanks.
Cool. Thanks.
Hi. So today the assumption for a lot of these tables is that these are append only, and the events that are coming in are append only. So the file ingestion sync that you spoke about, especially the sync mode and the incremental ingestion mode. What if there are use cases where they are not technically incremental, but we actually want to update existing records by some field? Would the file ingestion mode, in future support that sort of a use case? So essentially, it's incremental file ingestion with some sort of a key, and if records match that key, if you just upsert or you just replace the records.
So you wanna take
So there are three modes. So one of the mode is the sync mode. Actually, if the total number of the file, so because the sync mode will keep data inside Pinot to be synced with the source data, right? So if the amount of data source is not too large, then you can make use of the sync mode. As you add more files into the data source, the file ingestion task can keep sync of all of them. So if the source data is really a very large amount of data, and then it's hard to keep it in sync, then in this case, then I think we need to build some extra features to support the case. Yeah.
Yeah. So today we actually use sync mode, and we also repartition data just so that the sync will work. But I think having some sort of an incremental ingestion where it upserts existing records might be super useful.
Yeah, I think that's something, if not wrong, so that's something to be extended in the future. Yeah.
Hello. So I wonder if the sorting and the repartitioning Minion task is available on open source already?
Yes. Yeah, I can answer this one. So for the file ingestion task, the data preparation, data pre-processing like sorting, partitioning, that's already available in the open source side. But it's not like as a Minion task. It's actually a framework called segment processor framework, which is kind of like a library already inside the open source Pinot repo. So for file ingestion task, we just reuse that library to do the data pre-processing on the task executor side.
Okay, so if, say, we want to use this to repartition the data on our end, we'll need to write our own code for the Minion job.
Yeah, it might need kind of like a Minion task, which use this library to do the data repartitioning, sorting, those kind of stuff.
I see. So for the distributed like Minion execution, is there any sort of data passing or data shuffling like among these minions?
No.
Okay.
I think it depends on the Minion type, the task type. So we can potentially implement a new task type, let's say, which can do the data shuffle between the executors. I think that's something, if you really need data shuffling, it can be put inside the task executor. Well, for the two examples we show in the presentation, it doesn't have the data shuffling. Yeah. So everything just done within a single executor.
Mm-hmm. Cool. Thank you.
Cool.
Hi. Well, actually, you mentioned a few different jobs, but they are running asyncly from side to pool. So, or it's running synchronously towards your pipeline. For instance, data reformatting is offline, is separate work, right? Mm-hmm. So if that's the case, don't you consider just using another generic engine doing that rather using Helix? For instance, using a Spark job, you can just define your logic by using SQL or using data frame. And then it will compare to a DAG and finish the paradigm partitioning, shuffle all the things there. Don't you consider just using that way? Yeah.
Yes, so I think we started with that. So we used to use those Spark batching system to do those data repartitioning, shuffling, and prepare some intermediate files, and then ingest those files into Pinot as segments. Well, the major pain point is for StarTree customer. So they don't really have, many of them don't have those Spark or Hadoop, those data infra. And they just want to grab like a StarTree Pinot and install it as a standalone program, just have everything kind of like either ingest data to the query side. So I think that's one major point we try to solve by kind of enhancing the Minion task framework, which is because it's a native part of Pinot. So users just need to install Pinot as a alone and have all those data processing out of box.
Yeah, thank you.
Yeah, thanks for attending.